let I be the integral of the square root of cosine t minus the square root of sine of t between pi over 6 and pi over 3. We want to compute this value that we called I. We can, if we don't know one simple result that we can use here, we can do a change of variable, and we can get rid of the square root to solve this value. Okay, but we're gonna use a change of variable that we have seen in the previous video to find this result. In fact, we proved that the integral of f of x dx between a and b is the same as that of f of a plus b minus x dx between a and b. In our case here, f is the square root of cosine t minus the square root of sine t. A is pi over 6 and b is pi over 3. That's what we're going to use here. Okay, let's do that. In fact, we have I is going to be the integral between pi over 6 and pi over 3 of cosine t minus the square root of sine t dt. We can use our change of variable. Now, the bounds, they will not change. Okay, but our function will change. Here we have the cosine, so our f is going to be f of a plus b minus x. In this case, a plus b is going to be pi over 6 plus pi over 3, which is going to give us pi over 2. Okay, and therefore we have cosine of pi over 2 minus t minus the square root of sine of pi over 2 minus t dt. Okay, but we know that the cosine of pi over 2 minus t is just a sine, and sine of pi over 2 minus t is just a cosine. Therefore, we have pi over 6 pi over 3 square root of sine of t minus the square root of cosine of t dt. And what do we notice here? Notice this I here. Okay, so we can see that this one has a minus. Therefore, I is minus the integral between pi over 6 and pi over 3 of that of cosine, square root of cosine t minus the square root of sine of t dt. And that means I is equal to minus I. And this gives us that 2i is 0, and therefore I is 0. Okay? This proves that the value of I is 0. Okay? So we used this change of variable here to arrive to this result here. We use these facts here. Okay? There is another way. So this is very quick. So we arrived at this result very quickly. Well, if we want to do this one here, okay, we can do a change of variable, but that one will require some work. Okay, and there is another technique that we can use. Okay, but we're gonna see it in another video, not here. Okay, so this is an application of. This is very a very easy way to simplify problems. So it's not easy. This integral looks very complicated, but if we know this one, we can make it very easy and arrive the result very quickly. Thank you.